Hello and welcome to the section 12.1 lecture today. Today we're going to be talking about the Pythagorean theorem and finding missing side lengths of right triangles. All right, so in words, the Pythagorean theorem talks about a right triangle, and it says the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Important ideas in here. What is a leg and what is a hypotenuse? Legs are the two sides in a right triangle that are perpendicular to each other, so they meet at the right angle. And the hypotenuse is the third side, the longest side, the side that is not perpendicular to either side, or to any side, I should say. And so really what we get out of it is that a squared plus b squared equals c squared. And you'll hear a lot of people talk that that's not really correct, that it should be leg squared plus leg squared equals hypotenuse squared. Right? That's a little bit better. It's a little more direct as to what we're figuring out. But we're going to use these ideas today to try to find some missing sides of right triangles. So in this first one, I've got a triangle with a leg of 5 and a leg of 12. These two are legs because they are perpendicular to each other based on that right angle symbol. So that means that 5 squared plus 12 squared is going to be equal to x squared. Now to solve this, there's a little bit of work involved. First of all, I have to know what 5 squared is. That's 25. Plus 12 squared, which is 144, is going to equal x squared. And then 25 plus 144 is 169. And 169 is actually a perfect square. And I'll show that right here. If I take 169 and I square root it, I get 13. So that means that x is equal to 13. Okay, so kind of bringing in a new idea that in order to figure out what x is, if we know about x squared, I do want to be square rooting that to figure it out. The calculator is going to be handy today to do that. Otherwise, a lot of that work would be really tough to do. In the next one, I have it looks like a leg that's 9, and in this one, the hypotenuse, I always know it's the hypotenuse because it's across from the right angle, is 15. And I'm looking for the other leg. So if I write that in the form of the Pythagorean theorem, it would say that 9 squared plus x squared is equal to 15 squared. Well, if you don't know what those are, that's okay. You can always figure out what something is squared by multiplying it by itself. 9 times 9 is 81. And 15 times 15 is 225. And now to solve this, I want to subtract 81 from both sides. So I'm going to go ahead and check 225 minus 81. Gives me 144. And again, that's x squared equals 144. And then to solve that, I want to take the square root. Well, if you know it, great. If you don't, use a calculator. It's going to tell you that it's 12. So x is equal to 12. And if we wanted to be, strict about these, I'd say that this is 13 miles, this one's 12 yards. I'm more just looking, can we get the main idea of Pythagorean theorem out there? This one, I've got a decimal already, so that's not going to work out too well for me. I'm probably going to be stuck with a decimal throughout this whole thing. 8.2 and 13 are both legs. And so in this one, we're looking for the hypotenuse x. And so I need 8.2 squared. I'll just multiply it by itself. That's usually easier than hunting down the squared button. 13 squared, I talked about that earlier. It's 169. and I want to take this and add 169 to get 236.24. Oops. How about 0.24? That's what x squared is equal to. Now, this is the tricky part, is I do need to take that and take its square root. So you're going to have to find your square root button, and I get 15.37. 15.37. In the last one I have, I'm looking for a leg again because it's one of the perpendicular sides. So let's say x squared plus 8.9 squared is equal to 10 squared. I'll need 8.9 squared is 79.21. And 10 squared is 100. I'm going to subtract 79.21 from 100 and get 21 point, what did that say? 79. Now, in order to solve that, I need to take its square root. And we get 4.56. We're going to round it. 4.56. Okay. Now, what's used more often than anything when it comes to Pythagorean theorem is that there's a set of different three-sided triangles that are guaranteed to be a right triangle. And that's if I have a triangle that has a length of 3, 4, and 5, I'm guaranteed that that's a right triangle. So the way we use that is that if I'm looking at a triangle and it has a length of 3 and then another length of 4, I know that that third side is 5. Okay, I know that it is, if it's a right triangle. So kind of, both sides going on in each one of those. And it does say down there at the bottom that the largest number in each triple is the length of the hypotenuse. That's guaranteed. What's not so obvious is that these columns produce multiples of this 3, 4, 5. Granted, there are these other triples. There's the 5, 12, 13, 8, 15, 17, and 7, 24, 25. My main thing that I want you to track down and get a hold of is really this column here. This is something that I think that we should all know and be able to use. But that doesn't just mean knowing that sides of 3, 4, and 5 make a right triangle. It's also 6, 8, and 10, 9, 12, and 15, and so on. Now, the thing that we do need to know is that we do need to know that we have a right triangle in order to use these, but that's given to us with these pictures. Okay, so in this first one, I'd like to try to think if it's a 3, 4, 5 triangle, a 5, 12, 13, 8, 15, 17, or 7, 24, 25. But in order to figure that out, I need to know some things that are multiplying to give me these numbers. Okay. For instance, I know that 18 is 6 times 3. And I'm just taking a shot in the dark here. I'm not sure yet. And then 30, yeah, it's 3 times 10, but it's also 6 times 5. And this is the hypotenuse. This is one of the legs. So this triangle, from the looks of it, is a 3, 4, 5 triangle. This side over here being the 6 times 4. And it's just that 3, 4, 5 triangle expanded to a scale of 6. Like every side's been multiplied by 6. Okay. And so again, in order to figure some of those out, we need to know some ways to multiply to get some numbers. I think the first time I thought of this, I thought, well, this is 3 times 10. This is 3 times 6, so like a 6, 8, 10. And it does work out that would help us. But to see it as a 3 4, 5 triangle, we need to think of it as being multiplied by 6. So that missing side, without doing any of the work, is 24. Okay. And that can be a way to quickly get through some problems, okay, without having to square things and then square root and all that pain. This is a quicker way. And then when it comes to some of these other triples and using some of these other triples that we have here, it really comes down to knowing things that multiply to give you different numbers. For instance, I know that the only two numbers I could pick to multiply to 14 are 2 and 7. So if this fits a Pythagorean triple, it's going to fit this one that involves 7. Okay. And I can see it right here that it shows up as the second one on the list because it's times 2. For instance, 48 is 2 times 24. So I have a 7, 24, 25 triangle that's just been doubled. So this missing side is going to be 2 times 25, telling me that x is equal to 50. Okay. Anyways, put any questions you have over on the left. Otherwise, I hope you have a great day, and we will see you in class.